All right, so find the shadow cast by a 10-foot tall lamppost when the angle of elevation of the sun is 58 degrees. Find this length to the nearest tenth of a foot. All right, so we're finding the length of the shadow. All right, so we've got a lamppost here. Keep it simple there. We'll call that 10 foot tall. And we're trying to find the shadow that's cast. So let's put the sun up here, and we'll draw the shadow this way. All right. I don't know if it's shorter or longer. Doesn't matter really. Could be right there. All right, but that's our x. That's the thing we're solving for. All right, so it says the angle of elevation. So they're measuring from horizontal. They're measuring in an upwards angle. All right, so from the angle that we have here, it's actually going to be, that's going to be their angle of elevation. So I mean, it can't really be, from the sun pointed downwards, because there's no way that you can be at the sun, measuring the 58 degree angle downwards. You just can't do that. All right, so from here we've got the angle of elevation is 58 degrees. All right, so they're measuring towards the sun that way. All right, so once you have the triangle drawn, it's not too bad of a solve. We've got the opposite and the adjacent sides here. So that's going to be tangent of 58 degrees. And tangent is equal to 10 over x in this case. All right, so we would multiply by x, and then we would divide by tangent. So this is just going to be 10 divided by tangent of 58. Sorry, 10 divided by tangent of 58. And we're rounding it to the nearest tenth of a foot. So here, the 8 is going to cause that 4 to bump up, and then that 4 is going to cause that 2 to bump up. So it's going to be 6.3. Got it. So the shadow here is 6.3 feet. All right. Those are kind of troublesome to think about, whether it was 58 degrees that way or 58 that way. But since it was an angle of elevation, we knew it had to be that angle there. All right. A ladder is leaning against a brick wall. Oh, I love these problems. So you got a brick wall. The foot of the ladder is 6 feet from the wall. All right, so foot of the ladder. So let's let that right there be the foot of the ladder. So we'll call that 6 feet. The ladder reaches a height of 15 feet on the wall. All right, so 15 foot up on the wall is about right here. So we'll call that our 15-foot mark. We'll call this our ladder here. Find to the nearest degree the angle that the ladder makes with the wall. All right, so we're trying to solve that angle, the angle that the ladder makes with the wall there. All right, let's call that x. All right, so from x, we are trying to, from x, we've got 6 would be our opposite side, and 15 would be our adjacent. The ladder itself would be the hypotenuse there. So we're going to use tangent of x is equal to 6 over 15, opposite over hypotenuse. You could simplify this if you wanted to, but it doesn't matter. We're going to use the inverse tangent here. All right, so inverse tangent of tan of x is equal to the inverse tangent of 6 over 15. This side doesn't matter too much because we're just going to cancel out, but this side is going to be our answer. All right, make sure you're in degree mode, but inverse tangent 6 divided by 15, 21.8. This time it said find to the nearest degree. So if we round that up, it's going to be 22 degrees. All right, so that's the angle created between the ladder and the wall, 22 degrees.